We'll move on quickly because we're running a bit behind schedule to the next and final presentation before the panel with Roy Prayikulam from Head of Professional Services at Inform. Please, welcome.
Hello, everybody. I know the hard Indian names. But yeah, so where do we are? In this session, I would like to share with you the experience we at Inform have made in applying AI technology within the fraud and risk prevention area. In particular, I would like to elaborate a bit upon the methods which we are using in order to detect fraud, new modus operandi involving fraud patterns, and also, let's say, to predict the probability of a payment default in a risk area, and also from a compliance part to detect anomalous behavior of, for instance, new potential onboarded merchants. So I would like to explain you a bit of which we are using. And next to this, I would also like to elaborate a bit upon why we at Inform believe that the approach of using a hybrid AI, like the combination of knowledge-based methods and machine learning-driven models, will make the difference in the area of fraud prevention and risk management. So, but let's first start with AI. So you already heard some things about AI. So basically, I can feel there's a whole buzz around AI. If I, for instance, take a look into magazines, there's not even one magazine which at least doesn't have a tiny article about AI, machine learning. So it has been seen somehow as the holy grail, the thing which can solve all our issues. Yeah, so might be, might not be. But for me, the interesting question is, why now? Because AI has been already there for decades now. The first neural network has been developed in the 50s. So SNARK was the example for that. We had computers solving small tasks like playing checkers. The 80s mainly were driven by expert systems making use of technologies like fuzzy logic in order to automatize decision-making in a human-like manner. Then, I don't know, but pretty sure many of you here in the audience in the 90s have heard about Deep Blue, the first machine able to beat world champion Kasparov. So AI is nothing new. Today we are talking about voice recognition, facial recognition, and so on. So we heard about biometrics. So why are we currently experiencing such a great hype in terms of AI? So from my personal perspective, it's because of, at that time, not all ingredients were there in order to, let's say, unleash the full potential of these kind of AI techniques. And I'm referring to ingredients like accessibility to affordable computing power and also the availability of data. Today, we have got both. If you, for instance, take a look at the devices we are all carrying around each day, so meaning our smartphones, these small, tiny devices have got more computing power and more data storage than supercomputers at that time. Meaning that if we take currently a look how we are living our daily lives, so AI is surrounding us everywhere. So we have got not only, let's say, I'm talking here about robot dogs or chess computers. It's more about also the hidden champions and also the ones more visible, like spam filters. Yeah, it's AI. Take a look at 10 years ago how much spam you had and take a look at today. Or the things which we are also using each day, like entering a text message. And while we are entering the phrase, it already predicts which next word I'm going to enter. It's not only about word recognition anymore. It's also about prediction about what are you going to enter. The next things are the more prominent examples like personal assistants like Siri, Alexa, and so on, and self-driving computers. But from our perspective, what exactly does it mean for our industry, so for the payment ecosystem? So this means that we are all already in the way, let's say, we are changing our expectations towards technology. People, let's say our customers, and I'm also referring to me being a customer, we are we are already changing our expectations. We are expecting from our service providers that they are already enabling me to use these kind of new technologies. Just to give an example, I personally wouldn't let's say, expect anybody to ask me in some years to carry around long passwords or, let's say, hardware tokens in order to authenticate myself while making a purchase. I would expect that I'm also having the possibility of authenticating myself via biometrics and so on. You already heard it now today several times. And we also have got new regulations, which also are, let's say, encouraging us to make use of these kind of new technologies. So PSD2, strong customer authentication, and so on. And next to this, the technology is proceeding with a fast pace. We will see much more devices entering the market, wearables, there are new interaction possibilities on the market. So we're already seeing that there are new kind of payment schemes being used. I'm not only talking about Apple Pay or Samsung Pay, but we also see Fitbit Pay, Garmin Pay. So there are much more to come. So this means with all these kind of interaction possibilities, with these kind of new payment, let's say, methods, each of them has got their own fingerprint, their own strengths, and of course also their own weaknesses. Meaning for people like us working in the risk and fraud area, this comes also with a challenge. We need to make sure that the overall security level which we are currently providing to our customers stays the same, or even be better. So, of course, we need to make sure that when we are introducing new kind of methods to secure these kind of new payment channels, we need to make sure that these kind of methods won't, let's say, reflect to the user expectation in terms of convenience in a negative manner. So it shouldn't be that we always ask for passwords and so on, because then we can make things secure, but the user convenience, the user experience will get lower. So therefore, we need to make sure how to deal with this. And today, as said, we have got the possibility of having bigger data sets. We can have a look into each and every kind of details, but on the other side, we are all human beings. It is not so easy for a human being, let's say, to take a look at terabytes of data and to say, okay, that's the pattern. So that's what we are having to take a look at. And this is where machine learning can help. So machine learning can help us to take a look at the spot where we should invest into to find for us the patterns which are interesting to detect animal use behavior. So this is where machine learning can assist us in a manner that we can take the look at the right spot and not like being overwhelmed with all the kind of data which we have. Before going a bit more into detail of machine learning, I would like to put it into context with the term of artificial intelligence. So I already used artificial intelligence as a term. I used machine learning as a term. Sometimes you can also see that people want to talk about machine learning, but mean actually artificial intelligence, vice versa. So what it is all about. So basically, artificial intelligence is a concept of a machine being able to mimic human behavior. This means a machine needs to also have the possibility to represent the knowledge it has, also in fuzzy terms. It needs to be able to make automated decisioning. It needs to be able to solve problems by using solvers and so on. It needs to perceive and act, so like data gathering. And, of course, there is a part of the part of learning new aspects from the data given. And this is where I would like to focus upon the machine learning part. So machine learning basically means the machine is able to detect or to gather more knowledge, more information out of given data. From a methods perspective, I would like to focus on two methods which we are using within the area of detecting fraud and also in the area of detecting anomalies. So there we are referring to supervised learning and to unsupervised learning. What is the difference of this? So with supervised learning, we mean that the data we are giving to the machine has got clear labels. We can divide it into this was a fraudulent transaction and this was a legitimate transaction, meaning we can really classify this out of the feedback we get from our customers, out of the investigation results, and so on. Meaning we are already telling to the machine, there are two classes of data, legitimate ones and fraudulent ones. Take a look at these classes and find out what are the common spots so that we can predict for the next transaction to come in which class would it fall. Taking a look at what the machine has learned out of it. So like detecting the patterns which are in common. This is what we are using for detecting of, let's say, new modus operandi, new fraud patterns, or also to predict what is the probability of a payment default, because it's the same. We have got data where we can say, okay, this payment has been made, this payment had not been made. And then we can just say, okay, do we see there something in particular where we can predict for the next checkout, the likelihood of the payment default is high, therefore we shouldn't go for let's say, post-payment. We should ask for a prepayment. The next thing is the unsupervised learning. So when are we using unsupervised learning? Unsupervised learning we are utilizing when the data which we have, the historical data set, if either we don't have these kind of labels which really says, yeah, this has been fraud or not, or if we can't really trust the quality of this data. What are the use cases where this is typically the case? Think of insurance fraud or application fraud. Basically, the fraudster is your customer. If you, for instance, defraud your insurance, then if it works out, you are not going to call the insurance, got you. So you are just happy, it worked out. So nobody will complain, the insurance paid out the money and you are happy, everybody is happy, so it's a happy state. So no feedback, we don't know what went wrong. The same like with application fraud. If you now apply I'm a flower shop, I want to have the rates for a flower shop, but in the end you are acting as a nightclub. Yeah, if you don't go and check, then you don't know it. You don't have this kind of data available. Therefore, we are making use there of unsupervised learning, meaning to give to the machine data of, let's say, flower shops, in order to see, is there one flower shop which really acts a bit different, has got other kind of behavioral pattern than for the other flower shops. So this is where we make use of clustering and anomaly detection. And now, a bit away from the whole theory. So this is, let's say, how such a model, in this one example of a model in a supervised manner, can look like. So what you can see there on this, on the left side, this is an example of a decision tree. You need to think about, we have given data to the machine, and the machine started to take a look at the defined classes, like this is fraud, this is not fraud, or this has been paid, this hasn't been paid. It starts to cluster, let's say, not to cluster, it starts to create a decision tree based upon, it takes a look like, okay, take a look like, what are high value amounts, what are low value amounts? And each of these nodes means there has been a decision being made. And the machine takes a look at where the majority of the payments went through, so this is the thicker line, and then it always takes a look at, okay, what if we would have taken this decision and that decision, so it ends up into multiple, let's say, decision routes and leaves. The green ones are the one where the transaction ended up being legitimate, and the red ones are the one where the transaction ended up being fraud. And of course, these are the ones which we are mostly interested in. So the thing is, that's what we are then like to see are the ones where we have got many decision nodes and which ended up into fraud. And by applying these kind of explainable machine learning methods like decision trees, we can take a look into, okay, what was now the pattern? I have to admit, this seems to be the PDF version, there was an animation so far, so I could also have now unrevealed what would have been now the indicators. So basically, imagine when we take a look at this kind of the very small example of this node there on the right side. There, it might be that it says, okay, if this is a new card, if it has been used in a high-risk country, and if it had got this and that kind of payment before at that merchant, then it led to fraud. So this is something where we can also extract knowledge out of such a detection model. And this is a very simple example of a supervised learning method. Typically, we are combining multiple decision trees created in a random manner, and this is typically called random forest algorithm. So meaning there are many kind of algorithms which you can use, but we typically here, in our case, go for explainable algorithms, so that in one thing is that we have got made very good experiences with prediction rates above 90% in terms of can that lead to fraud or not. And the other part is we can really see what was the difference, what led to this kind of decision. So it's not a black box approach. The next thing is like the unsupervised learning. I already told you, this is when we take a look at data where we don't have these kind of classification attributes. And I already gave you the example of, let's take a look at flower shops which are behaving differently, like a high-risk merchant and so on. If you have just a ton of data, it's very hard to find what is now where we should have a focus upon. But if you apply machine learning, it can just create these kind of things, where you directly see, okay, there is an outlier. I should take a look at these specific merchants. Why are they behaving different? So this is where, again, machine learning can help you to cluster the data in an automated manner. And these kind of models which I'm showing here, today this is not any batch process anymore. It's just like this being applied in real time. So with each transaction which you are doing, these kind of trained models can be applied, and it will already create an alert if a transaction fits into this or that kind of profile, or if it deviates too much from the normal behavior of the peers. So this is where machine learning can really help us in boosting the detection rate. Something I would like to also mention is machine learning is data-driven. Therefore, this is an example I took from a website called tylerwiggin.com. So Tyler Wiggin is a Harvard student which really focuses on finding correlations within data, which doesn't really make sense, but these correlations are there. And what I want to point out there is that there are so often, when I discuss with our customers, they have the impression the more data, the better. And I slightly disagree. It's not about having more data. It's about having the right data for the issue you want to tackle. And here's an example. When you take a look at here, Tyler Wiggin just took data of several years and put all kind of data sets together he had, and the machine found such a very interesting correlation. Meaning, here the machine said that there is a very strict correlation, and we can see this with the graph, with the number of doctorates awarded in the US for sociology with the number of non-commercial space launches. So there is a correlation. So the machine would now tell you, if you ask the machine, raise the spend for educating doctorates in sociology, then we can fly faster to the Mars. So this is something where you need explainable AI for, to detect these kind of correlations where we as a human being know, okay, this is a correlation, but it doesn't make sense. So therefore, you make use of explainable AI. And the next thing I would like to emphasize upon is what I in the beginning said, make use of hybrid AI approaches. Because currently, and that's what I also wanted to mention, everybody is talking about AI being the holy grail, being able to solve everything. But don't forget about the expertise you already have gathered around the last years. So the first thing is machine learning is data-driven. And machine learning will find things which are in the data. On the other side, when I, for instance, refer to Fitbit Pay, if I would ask you, can you give me a sufficient amount of Fitbit Pay transactions for the machine to learn? How many of you would say, yes, I have it. My database is full of Fitbit Pay transactions. You see, I expected this. And therefore, does it mean that we have to accept Fitbit Pay transactions without any kind of security layer? No, we as human beings, we know that there are patterns out there when we see there is a huge frequent use of Fitbit Pay in specific areas, in time zones, unusual for the customers. So we have got already possibilities of profiling customers, of making use of, let's say, knowledge we already have, of making use of fuzzy logic scorecards and so on, in order to not only rely upon machine learning. But machine learning helps. Therefore, we believe in the hybrid approach. Apply both words and make the use of both words in order to have a very good security net. So this is what we at Inform with our solution Risk Shield utilize. What we do is a transaction comes in, we take a look at everything which we know about the specific transaction, about the merchant, about the card, about the relationship, about the IP addresses, and so on. So from a knowledge-based perspective. And then one of the additional parts is machine learning. And the overall detection rate, this will then define what is the output. How do we have an alert? Are we going for a specific payment type? Are we going to block this transactions or not? So this is where we believe should be the journey we should head to, because machine learning, for sure, it helps. And this is also something we have to invest in, we need to use. I also believe there is no way around making use of machine learning, but it shouldn't be like the one or the other. And yeah, finally, what I wanted to tell you in this short session is machine learning, yes, it works, but make use of it in a good manner, meaning make use of explainable AI, be able to control it, be able to understand what the machine learned. And then take a look at that it's not like that one machine learning model solves all kind of issues you have. It's about the specific issue you have. Take a look at which algorithm you want to use. Take a look at which data you want to provide. It's not like put all data in it and we have got a benefit. Really take a look at what is the issue you want to solve and tackle it with the means you have available. And the next thing is data, of course, isn't anything. It's not only about machine learning. It's also about the knowledge we as human beings have gathered over the years, and don't forget about it. Yeah, then I hope this was interesting for you. I know for times AI might be a bit hard to listen to, but if you are interested in knowing more, if you have got specific kind of issues which you would like to discuss, please feel free to approach us at our booth. And me and my lovely colleagues, we are there to answer all your kind of questions you might have. Thank you very much.
Thank you. Awesome.